In this video, we're going to look at the relationship between the cell potential and the free energy change for a galvanic cell. So the free energy change for a redox reaction is related to the cell potential for that reaction according to the following equation. So the change in free energy is equal to negative NFE, where of course delta G is our free energy change for the reaction. N is the number of moles of electrons transferred between the anode and the cathode. F is Faraday's constant, which is given in coulombs per mole of electrons. And E is the cell potential. A coulomb is the amount of charge transferred when a current of 1 amp flows for 1 second. A coulomb is equal to 1 joule divided by 1 volt. So we'll use this relationship in a little bit. So Faraday's constant is the charge on 1 mole of electrons. So we showed you that Faraday's constant is 96,500 coulombs per mole of electrons. We can change the coulomb into a joule per volt. And you'll see that this is important because generally free energy is expressed in joules or kilojoules. So we want to get it in those terms. Okay. So we saw the relationship between free energy delta G and the cell potential E. If we set up a galvanic cell or a reaction, a redox reaction under standard conditions, then of course our reaction just becomes delta G standard is equal to negative N times Faraday's constant times the standard cell potential. And there's a relationship that we want to look at. The relationship E standard, the larger, more positive this E gets, then the more negative, because we have a negative sign here, the more negative delta G or delta G standard will be, which means reactions that have a large positive cell potential will have a large negative delta G. So reactions that have a positive cell potential will be spontaneous under those conditions. So that's an important relationship to appreciate. So let's take a look at a problem to help us use our equation. It says calculate the standard free energy change for this reaction at 25 degrees Celsius. So I'm going to put up a table that you may need. And when I do, pause the video and see if you can solve this problem. Okay, so to calculate the standard free energy change, we need to figure out the number of moles of electrons. We know Faraday's constant. And we need to figure out the standard cell potential for this redox reaction. To calculate the standard cell potential, we need our standard oxidation potential plus the standard reduction potential. Looking at this, I can see that zinc is losing electrons, so this zinc is undergoing oxidation. So I need the standard oxidation potential for zinc. The copper is gaining electrons from +2 to 0, oxidation numbers. So I need the standard reduction potential for copper. We get those from our table. The standard reduction potential for copper is 0.34 volts. The standard reduction potential for zinc is negative 0.76 volts. Of course, zinc is being oxidized, so we have to flip the equation to get it to be oxidized. And when we do, we change this voltage from negative 0.76 to positive 0.76. So our equation for our standard cell potential becomes 0.76 volts. That's the oxidation for the zinc, the oxidation potential. And we add to that 0.34 volts, and that's the standard reduction potential for the copper. So we get an overall standard cell potential of 1.10 volts. We can substitute that right in here. Now also, if we look at this, we see that zinc is losing 2 electrons and copper is gaining 2 electrons. So there's a net of 2 electrons being transferred. 2 are being lost from zinc, 2 are being gained from copper. And we can see that from the half reactions as well. So our moles of electrons being transferred here are 2. So 2 moles of electrons times Faraday's constant. Here I've expressed Faraday's constant in joules per volt per mole of electrons because delta G must be in joules or kilojoules, and we multiply times that our standard cell potential. The volts will cancel, the units, the moles of electrons will cancel, and when we solve for delta G standard, we get negative 2.12, 212,000 joules, or we can express that as delta G standard equals negative 212 kilojoules. So please be sure that you know when to use this equation, and be sure you can figure out the number of moles of electrons, and remember to calculate how to calculate the standard cell potential.